In this lesson, we will learn how to find the volume and the surface area of cylinders and rectangular solids. Let's begin with volume. Volume is the amount of three-dimensional space an object occupies, and it is measured in cubic units such as cubic inches and cubic meters. For example, a cubic foot refers to the amount of three-dimensional space that is occupied by a cube that has measurements 1 foot by 1 foot by 1 foot. Now please note that on the GRE, the cubic units are sometimes implied. So for example, we might say that a certain object has a volume of 10, by which we mean 10 cubic units of some kind. Okay, now let's say we want to find the volume of this rectangular solid, also known as a rectangular box. Well, the formula for finding the volume of a rectangular solid tells us to multiply the length by the width by the height. So the volume of this particular object will be 2 times 3 times 5, which equals 30. So this rectangular solid, or box, has a volume of 30 cubic feet. Okay, now let's learn how to find the volume of a cylinder. To find the volume of a cylinder, we need its radius r and its height h. The formula tells us that the volume of a cylinder is equal to pi r squared times h. So, for example, to find the volume of this cylinder, we will call up our formula, and now replace the radius r with 3 and the height h with 10. When we evaluate this, we see that the cylinder has a volume of 90 pi cubic units. Okay, so that was volume. Now let's look at surface area. We will begin with the surface area of a rectangular solid. Now before we go any further, we should discuss 3 terms that are related to rectangular solids. First, a rectangular solid is formed by rectangular surfaces, known as faces, and there are 6 faces altogether. We can see 3 of them here, and 3 more are out of sight. Next, the lines where the faces meet are called edges, and there are 12 edges in total. And finally, the points where the edges meet are called vertices, and there are 8 vertices altogether. Okay, now let's find the surface area of a rectangular solid with the following dimensions. The total surface area of this box will be the sum of the surface areas of the 6 rectangular faces that make up this box. Now to make it easier to see the various faces that make up this box, let's look inside. Here we can see that this face in the back is identical to the face in the front. So let's find the area of the front face, which we will move over here. Notice that this face has the following dimensions. Since this is a rectangle, we can find the area by multiplying its base times its height to get an area of 40 square centimeters. This is the area of the front face, so we can add this to our calculations. Now, since the face at the back of this box is identical to the face shown here, that back face will also have an area of 40 square centimeters, so we can add this to our calculations as well. Okay, we have now dealt with 2 faces. We have 4 more to go. Next, notice that this bottom face and this top face are identical. So let's find the area of the top face, which we can draw over here. Since this face has the following dimensions, its area will be 8 times 4, which is 32. So the area of the top face is 32 square centimeters, which means the area of the bottom face is also 32 square centimeters. So to our calculations, we will add 32 square centimeters and another 32 square centimeters. We now have 2 remaining faces to look at. We have the face on the left-hand side and the face on the right-hand side. These 2 faces are identical, so let's find the area of this face, which we'll move over here. Now the dimensions of this face are 4 by 5, so the area of this rectangle is 20 square centimeters, and the area of the other rectangle will also be 20 square centimeters. So to our calculations, we will add 20 square centimeters and another 20 square centimeters. Now when we add the areas of all 6 faces, we see that the total surface area of this box is 184 square centimeters. Finally, we will find the surface area of a cylinder. To do this, we must first recognize that a cylinder is comprised of 3 separate surfaces: the top, the bottom, and the curved part. Let's examine each surface individually. First, the top surface. This is a circle, so we can draw it down here. If we say that this top circle has radius r, then we can find its area by using the formula for the area of a circle, which is pi r squared. Now the area of the bottom circle will be the same as the area of the top circle, so let's add this circle down here as well. Finally, we need to find the area of this curved part. To do this, let's first say that the cylinder has height h. Now if we take the curved part and roll it out, we get a rectangle that has height h. So to find the area of this rectangle, we need to know the length of its base. Well, notice that when we unroll the curved part, the circumference of the circle becomes the length of this side of the rectangle. As such, the length of the rectangle's base is equal to the circle's circumference, which is 2 pi r. So the base of this rectangle must have length 2 pi r. Now to find the area, we will multiply the base of 2 pi r by the height h to get 2 pi r h. So the total surface area of a cylinder will be the sum of the areas of both circles plus the area of the rectangle. Now we can simplify this by adding the areas of both circles, or we can even factor out 2 pi r to get 2 pi r times the radius plus the height. Any of these will help you find the surface area of a cylinder. Okay, to summarize, in this lesson we learned how to find the volume and the surface area of cylinders and rectangular solids.